Hello everyone. In today's session, we are going to learn about the fundamentals of research methodology based entirely on the new curriculum and syllabus for MD Ayurveda first years. So all the points you'll hear today are carefully picked and organized from the latest textbooks and are sorted in such a way that if these topics are asked in exams, you'll know exactly what to write. So let's not waste time and dive in and make research methodology really simple and crystal clear. Alright, so let's begin with understanding the basics of research, like what research really is. The word research comes from the French word rechercher, which simply means to go about seeking, like searching for answers actively. Now, in more technical terms, research is the scientific method of gathering information and analyzing it to better understand a phenomenon, solve a problem, or generate new knowledge. It is not just random information collecting, it is systematic, orderly, and meant to help us make better decisions. If you just collect some random knowledge, it will not become research. It should follow a process, it should be systematic, it should be orderly, and it should help us make better decisions, solve a question in such way. So in fact, you can think of a research as a structured journey from a question to an answer. In other words, they are often used instead of research are search, probe, explore, discovery, verification. So all these give you an idea of digging deeper into something. So basically, research is equal to organized curiosity plus action. So that is what should come to your mind. And what is given here is like maybe the intro you can write if they have asked on this research process. You can just write a 2-word intro on what research is and then go into research process. And coming to the Ayurvedic perspective of research, we call it Anusandhana. Anusandhana is the term used for research in Ayurveda. In Sanskrit, this Anusandhana refers to the systemic investigation of the cause and effect relationship between the dravya, dravya, guna, and karma. There is a sloka which is Kari Karana Bhavasya Dravyanam Guna Karmayoho Parikshya Sthabanam Samyak Anusandhana Muchyate. So Anusandhana, according to P.V. Sharma, explains the study of cause and effect relationship between dravya, guna, and karma after several observation and thorough verifiable examinations, and then arrival at a final conclusion. That is what is research according to Ayurveda. And P.V. Sharma has beautifully defined it as a deep study through repeated observation and verification, leading to final conclusion. So even in ancient science like Ayurveda, they are very particular about proof and rechecking and proper conclusion, just like modern day research. Synonyms for Anusandhana includes Anveshana, Pareshana, Gaveshana, and Shodha, which are all basic terms which convey the same meaning, like search or investigate. So this shows that science and systematized inquiry have always been a part of Ayurveda too, not just modern science. Research is not just jumping into experiments randomly, as we came to know. It follows a very structured process. So first, we'll have to there are certain sequential steps that guide a researcher in conducting these process or these studies, which are listed below, which is known as research process. So what is research process? Research process comprises the systematic procedures that the researchers must go through in order to generate knowledge and to ensure that all parts of investigation are completed in high standards. So this research process allows the researcher to cover all the angles and ensure that the information they gather is reliable and effectively presented. and it involves sequential steps that guide the researcher in conducting rigorous and reliable studies. These steps are: first, selection of topic; second, literature review; third, defining research problem and formulation of hypothesis; fourth, defining aims and objectives; fifth, research design; sixth, sample design; 7, data collection; 8, data analysis; 9, generalization and interpretation; and 10th, method of communication of research. And maybe in some other books you may find after aims and objectives, materials and methods, then results and outcome, methods of communication. Basically, these research design, sample design, data collection and data analysis, this all comes under materials and methods. So, summarizing the same, first we start with selecting a topic. So that will spark curiosity, or it will fill the gap. Then what do? You do a thorough research of what, because the topic is interesting to you, you do a thorough research of the topic. That is, you do a literature review. You read what others have already found about that topic. Then next you define the research problem and sometimes create a hypothesis, basically predicting what you expect to find. So from that topic, you read about it, then you narrow down the topic to a certain problem, research problem. Then you create a predictable answer. After that, you set clear aims and objectives on what exactly you want to achieve. And then comes the research design, like the blueprint or plan of how you would carry out the study. This is followed by sample design and preparing your materials, that is your materials and methods, deciding on whom and what you will study and how. Then the data collection, which is also a part of this, that is gathering the data, information, everything, followed by data analysis, finding out the observations and analyzing the data through statistical tests, etc. Then finally you go for generalization and interpretation, interpreting and understanding what these findings mean. And lastly, you work on communicating your research to the world through papers, presentations or reports. So each step is built on the previous one. So if you rush or miss a step, the whole study will not be proper. Alright, so we'll discuss about all of this. So coming to the next most important topic, concept, that is literature review. So what exactly is literature review? Literature review is the writing process of summarizing, synthesizing and or critiquing the literature found as a result of literature research. It can be used as a background or the context for the primary research project. A literature review helps the researcher to learn about the history and nature of their topic and identify research gaps and problems. Here in the review, what you basically do, you dive into books, research paper, journals and see what's already known, what debates exist and where the gaps are. It's like preparing a full background check before you start your own research. And what are the benefits of literature review? To gain familiarity with the current knowledge in chosen field, to gain a familiarity of the theories driving the field, to gain familiarity with the boundaries and limitations of that field. There will be synthesis of information, creation of new body of knowledge, and you'll get answers to a range of questions. So it helps us to understand the history and current status of the topic. Second, it lets us spot the research gap. Research gaps are areas where not much work has been done. Helps us to avoid duplication, so you don't waste time researching something that's already well established. And most importantly, it helps you set the theoretical framework your own study. So this is the purpose of literature review. First, contextual reference, then identify gaps, second, avoid duplication, and fourth, establish theoretical framework. And the benefits which have already been told is very important, like you become familiar with the existing knowledge, the theories behind it, and the boundaries of your field. Then you also get to create new synthesis, that is combining old knowledge in a new way. But is it all easy? No. So what are the disadvantages of literature review? It is time consuming. Sometimes it lacks quality sources, and many times people end up writing it too descriptively without critical analysis. So it's a crucial foundational step. Without a good literature review, your research will have weak roots. So the next thing is the main types of literature review. There are 4 types: traditional or narrative, systematic review, meta-analysis, meta-synthesis. These types are based on the aim and method and how you do it. First one is traditional or narrative review. So this one gives you a broad overview of the topic based on the existing studies without a strict method. It's more general and flexible. It is good for understanding wide topics. So this type offers a broad overview of a topic based on existing literature, and it often lacks a strict method. This is what you'll have to write. Second one is systematic review. Systematic review is very structured. You follow a rigorous method to find, assess, and synthesize all the research about a specific question. It is scientific, reproducible, and very reliable. So, systematic review employs a rigorous and predefined methodology to identify, evaluate, and synthesize all relevant studies on a specific research question. Third, then comes the meta-analysis. So this step goes further. That is, it statistically combines results from multiple studies to produce a single solid answers. When different studies tested a medicine, meta-analysis will combine all their results and tell you the final verdict. So this type statistically combines the result of multiple independent studies addressing the same research question to produce an overall or absolute effect. Lastly, meta-synthesis. This is mainly used in qualitative research. Instead of numbers, it synthesizes ideas, themes, and understanding from multiple studies to build a new interpretation. This type synthesis qualitative research findings to develop new interpretation and understandings of a phenomenon. So each type has its own role. So you choose them based on your research goals. And another classification of literature review is systematic review and scoping review. This is another way to classify reviews. Systematic reviews and scoping review. This is another way to classify reviews. Systematic reviews answers a very specific research question. They are narrow, focused, and statistically analyzed. Whereas scoping reviews, on the other hand, are very broad and explanatory. So instead of answering one simple question, they map out the breadth of evidence around a wide topic. They are less rigorous and more descriptive, basically summarizing what's out there. So simply we can put it like, if you have a sharp, narrow question, go for a systematic review. If you want to explore a field broadly, go for scoping review. So now, once you're done with your literature review, what was the next step? To identify the research problem. So research problem is a specific issue or gap or difficulty or contradiction in knowledge that a researcher aims to address through systematic investigation. So it is a specific issue or gap in knowledge that needs to be addressed. It can be anything unsatisfactory you notice, a contradiction or an unanswered question. So this is the base of your entire research. Without a well-defined research problem, your whole study can go off track. It can involve areas of concern or condition that might need improvement or difficulties that need to be eliminated. Any question you want to answer or any assumptions or statement that you want to challenge or investigate or examine can become a research problem. This research problem provides the foundation of the entire research process. Identification of research problem is the first and foremost step in research process. Generally, a broad area is selected and then a broad topic is delimited or narrowed down to a specific one-sentence statement of the problem. So this is how it is usually run. How you pick a broad topic and then you narrow it down into a very specific problem statement. So remember, research starts with curiosity, but it becomes scientific when you pinpoint the problem clearly. Deeper into the cause-effect connections, like does smoking causes lung cancer, the classic one. Here you're finding the actual cause behind an effect. It is directional, structured, and no manipulation is required in such kind of research problem. So in short, in descriptive, we just see what is happening. In relational, we see are these two related, and in causal, what is causing what. We see what is causing what. That is the gist of all this. Okay, so once the research problem is set, the next step is to frame the research question. A research question is a clear, focused query that guides a study aiming to investigate a specific issue or problem. A research question is a clear, focused question that your study will try to answer. Now, many students confuse topic, problem, question, and hypothesis. So here is an easy way to remember. Research topic is the broad area you're interested in. For example, like child nutrition is a broad research topic you're interested in. Then comes the research problem. So research problem is the specific issue within the topic. Within that topic, like high rates of malnutrition in toddlers, that comes under child nutrition. Malnutrition in toddlers is a specific issue within that topic of child nutrition. Then it's the research purpose. Why you want to study this, like to assess factors causing malnutrition. And then the research question. So research question is a clear question you will investigate, like what are the socio-economic factors contributing to malnutrition in toddlers. It's a research question. Then comes the hypothesis, which is a testable prediction based on that question. So if you arrange them correctly, your research will have a solid backbone. So now research questions can be classified based on the type of study into qualitative research question and quantitative research question. Qualitative research questions focuses on ideas, experience, and feelings. Examples include exploratory questions, predictive question, and interpretive question. Exploratory questions like, for example, how do teachers feel about online education? It's an exploratory question, you explore. Interpretive questions, what meanings do patients associate with their illness? And predictive questions. So these are the three types of qualitative questions. On the other hand, quantitative questions deal with measurable things, that is numbers and data. Examples of qualitative questions include descriptive questions, comparative question, and research-based question. Descriptive questions like how many students score above 80% in so and so this thing. Comparative, like comparing difference between online and offline exam scores. Research-based question. So these are the different types of research questions. So basically, if you're trying to understand human experiences, you go for qualitative type. If you're trying to measure or compare, you go for quantitative type. Once you frame your research question, how do you know it's a good one? There are different criteria you use for that. First one is simple. We use the finer criteria. FINER, finer criteria. F for feasibility, I for interesting, N for novel, E for ethical, R for relevant. F is feasibility. Feasibility means, is it realistic? Can you collect enough data, manage time, money, and technical demands? A good research question is feasible, which means that the question is well within the researcher's ability to investigate. Researchers should be realistic about the scale of their research as well as their ability to collect data and complete the research within the skills and resources available to them. Here we check if there is adequate number of subjects, adequate technical expertise, affordable, if it is affordable in time and money, is it manageable in scope. So the research question should be answered under the objective aspects like time, scope, resources, expertise, or funding. All this comes under feasibility. This has to be checked after you select a research question. If it is not feasible, then it is better not to take it. Then I, interesting. So interesting, regardless of your own personal motivation about a subject, it's more important to check if your question corresponds to more practical and broader interest. Not just for you, but it should be interesting for others too. If it's boring, what will happen? Nobody will care about your findings. So the ideal research question is not only interesting to the researcher but also to their peers and community. So the interest boosts the researcher's motivation to see the question to be answered. The third one is N, novel. Is your research bringing something new, or either confirming, refuting, or adding something fresh to existing knowledge? So this is what you mean by novel. Does it answer an existing gap in the knowledge? So filling one of these gaps is important. So your research question should be developed to bring new insights to the field of the study you're investigating. It should either confirm, refute, or extend previous knowledge. E, ethical. Can it be conducted ethically? Will it be acceptable to an ethics review board? This is one of the most important considerations you have to consider before making a research question. R is for relevant. Will it contribute meaningfully to science, society, or public interest? So all these has to be checked. So aside from being interesting and novel, the research question should be relevant to scientific community, people involved in your area of research, and if possible to public interest. So a question ticking all these boxes is worth investigating. Another powerful tool to frame sharp questions is good questions is the PICOT framework. It was first introduced in 1995. It's PICOT, PICOT framework. So P stands for population, that patients or problem. So like, who are you studying? I is intervention or indicator being studied, like what are you doing to them? C is comparator or comparison group. What are you comparing it with? O is outcome of interest. What result are you expecting? And T is time frame of the study, in which what duration you're doing it. For example, if you're studying the effect of Basti therapy in children with cerebral palsy compared to those undergoing physiotherapy, your population would be children with cerebral palsy. Investigation would be Basti. Comparison would be with physiotherapy. O would be increased movement, and T is the specific time period of the intervention. There is a simple version, there's a simple framework similar to PICOT framework, which is commonly used in qualitative research, that is PEO framework. PEO, that is population, exposure, and outcome. These frameworks give sharpness to your research question and make your study focused and effective. Alright, so moving ahead, after the research question comes the hypothesis. A hypothesis is a testable prediction. So, it is a testable statement that predicts the relationship between two variables. A hypothesis is a testable statement that predicts the relationship between two variables, meaning it is a testable prediction, a logical guess based on existing knowledge. So once the research question is defined, the next step is to formulate the hypothesis, which is a tentative explanation that can be tested through empirical research. The hypothesis serves as the working theory for the research, and it is crucial for directing the inquiry. There are two types of hypothesis: null hypothesis and alternative hypothesis. Null hypothesis assumes that the relationship there is no effect or no relationship between the two variables. Null hypothesis suggests that there is no significant relationship between the variables. It is tested to be either rejected or accepted based on the statistical evidence. For example, like we took the other example in Picot framework. For that question, if you're framing the null hypothesis, it would be there is no difference between Basti therapy and physiotherapy in children with cerebral palsy. There is no difference. The alternate hypothesis proposes that there is an effect or a difference. That is, it is tested against the null hypothesis. For example, in alternate hypothesis, it would be Basti therapy leads to a better improvement than physiotherapy. So research is mainly about collecting data and testing these hypotheses statistically, and then accepting or rejecting the null hypothesis. So how to make sure your hypothesis is a strong one? So there's a simple checklist of or characteristics of a good hypothesis. It should be specific, measurable, logical, and testable. Specific as in it should clearly state which variables are related. It should clearly define the relationship between the variables. It should be measurable, able to collect data to test it. It must be capable of being empirically tested either to experimental data or through observational data. It should be logical, that is, it should be based on solid background research. It should be logically derived from existing literature. And it must be testable, that is, it should be tested through experiments or observations. In short, your hypothesis must not be vague. It should be something you can prove or disapprove practically. So what are the key functions of a hypothesis? First, directing the research. Second, it is the basis for statistical testing. You can't test something without a hypothesis. Third, it provides a means to test existing theories or prepare new theoretical framework based on findings. So now finally, once your hypothesis is framed, how do you test it? First, you collect data. Data collection is done. That is, you gather information through experiments, survey, or observational studies to test the hypothesis. Second, statistical analysis. You apply tests to determine if there is sufficient evidence to accept or reject the null hypothesis, to see whether the data supports your hypothesis. And third is the decision making. If the results are significant, you reject the null hypothesis, and if it is not significant, means insufficient evidence is there, you fail to reject the null hypothesis. So research is all about scientifically challenging assumptions with real world data. So that's a complete overview of the basis of research methodology, from understanding what research is to how to select a research problem, frame question, and test hypothesis. So I hope this session helped you get a clear idea about how research study is properly planned and executed.